Hi guys, welcome back to another lesson in geometry. Today we're going to look at different types of quadrilaterals and how to calculate the angles of different quadrilaterals as well. Let's jump in. So let's begin by recapping what is a quadrilateral. So a quadrilateral is a 2D shape that has 4 sides and 4 angles. So we have here 4 sides and 4 angles. Now there's plenty of different types of quadrilaterals, and some of them we call regular quadrilaterals and some of them we call irregular quadrilaterals. This one is an irregular quadrilateral, and I'm going to let you think about why that might be. Now, all 4 angles add up to 360. So like a triangle, that add up to 180. A quadrilateral, if it has 4 angles, adds up to 360. So A plus B plus C plus D equals 360. Let's look at a couple of different types of regular quadrilaterals, we'll begin with parallelograms. So a parallelogram has opposite sides that are parallel and equal in length. So this length here, AB and DC, are equal in length, and AD and BC are also equal in length. And we say that opposite angles are also equal. So this angle here at A and this angle at C are equal, and this angle at B and this angle at D are also equal. Then we have a rhombus. Now rhombus is similar to a parallelogram except that all 4 sides are equal in length. So just like a parallelogram, when we talk about the angles, opposite angles are equal. Then we have a rectangle. Now a rectangle is nice and simple. We've got 2 different sets of lengths and all 4 angles are 90 degrees. A square, so similar to a rectangle except that all 4 lengths are the same length and all 4 angles are 90 degrees. Now, let's talk about a kite. So a kite, you should know the general shape of a kite because it is like the kite that flies through the sky, the typical one. And it has 2 pairs of side lengths that are each the same. So these 2 side lengths at the top are the same, and these 2 lengths at the bottom are also the same. Now, opposite angles on the edges, where the 2 different lengths meet, so the long length and the short length meet, they are the same in length, okay? So the dotted lines or the diagonals between the 2 meet at 90 degrees. Now that's important because we can use that to help us find third angles and things like that, remembering that this always equals 90 degrees. Then we have a trapezium. So a trapezium is where we have one set of opposite lengths that are parallel, but the other lengths that are opposite are not parallel. Now they can be different lengths, so this length here is longer than this opposite length, or they can be identical in length, and when they're identical in length they are an isosceles trapezium because they are the same length and these 2 angles at the bottom are the same and these 2 angles at the top, but that's only if these lengths are the same. Irregular quadrilaterals. Now, I mentioned these at the start, and irregular quadrilaterals have no special properties. They don't have any lengths that are the same, or they might, but not all of them. No rules that they follow. There's no rules to work out angles. It's simply that all 4 angles add up to 360. Now let's do an example. So here's an example of a kite, and as you can see, these 2 angles where the different lengths meet are identical. This top length is 95, so to work out x, we know that all 4 angles add up to 360. So we go 360, take away 95 plus 115 plus 115. Now if you're putting this into your calculator, you have 2 ways to do it. You can go 360, take away brackets, and then add all the lengths together. Or you could go 360, take away 95, take away 115, take away 115 without the brackets. And that would give you, so if we add all those lengths up, so it's 360 take away 325, so x equals 35 degrees. Thanks for watching, guys. Remember, if you have any questions, please make sure you ask. Otherwise, I'll see you in the next lesson. Thanks, guys.